Hello, everyone. Thank you for joining us for this episode of The Future of Highways. I am Dan Rizicki of the Transtec Group, which is a pavement engineering firm. And our guest today is Dr. Steve Schladover, a research engineer at the University of California at Berkeley. Hello, Steve. Thanks a lot for joining us today.
Hi, I'm pleased to join you.
So Steve has been researching road vehicle automation systems for about 4 decades now. So that makes him an excellent person to talk to us about the future of highways. So Steve, could you give us just a quick recap on your background and how you got to the role that you have today?
Sure. I started studying mechanical engineering at MIT back in the 70s, specializing in dynamic systems and control. Most people who worked in that field went into aerospace, and I decided I wasn't really that interested in aerospace. I wanted to work on something on the ground and something that was going to impact people's lives on a daily basis. So some ideas I came across at that point involved automation of driving, and that looked like a really interesting thing to get into. So I pursued that. I took a bunch of classes in civil engineering as well as mechanical engineering, and got to understand the transportation world as well as the world of vehicle dynamics and control.
Gotcha. All right, thank you. That's very interesting. And how much of that was in California versus other places?
Well, I studied at MIT, so that was in Massachusetts, and then moved to California. I worked for a company in Silicon Valley for 11 years, doing a variety of projects. And then after that 11-year period, the University of California, Berkeley got together with Caltrans to create the PATH program, which is the program on use of intelligent transportation system technologies to help improve road operations. So I joined PATH at that point after having 11 years of industry experience.
Gotcha. Okay, great. Thank you. So, so then as you were doing that work, how did you eventually get interested in focusing specifically on connected and automated vehicles?
Well, I'd been interested in automated vehicles all along, and the state got really interested in the idea when they did a long-term planning study to look at how they were going to deal with the growing traffic congestion over a long-term period, and realized they didn't have any physical construction alternatives that were going to be economically or politically or seismically viable. And the only way they were going to be able to deal with the growth of traffic in a state with a growing economy and growing population was to start using information technology. So we got involved with a variety of things involving traffic management systems, traveler information systems, but also, very importantly, automation systems. And at that time, we were the only program in the country that was dealing with automation. Most other people thought that was a little bit too futuristic, that it would never happen. And we thought, no, that's got a real possibility. But there are a bunch of technology problems that we have to work on in order to make it possible. So over the years, we did a variety of projects, starting with computer simulations and modeling, and then prototyping full-scale vehicles and doing tests on those vehicles, showing that we could actually control them effectively. We could control the steering of the vehicles, we could control the speed of the vehicles, and we could make them drive in a way that was comfortable and comforting to the passengers, that they wouldn't feel threatened or wouldn't feel unsafe by being in the vehicles.
So the idea of being able to have fully automated vehicles that are able to do sort of the autonomous driving that we talk about today, how long ago did that concept really kind of first become, something that people thought was attainable?
Well, that concept actually got first traction back in the 1930s, and there were futurists looking at it at that time. General Motors put together an exhibit at the World's Fair in New York in 1939 called the Futurama that showed a vision of how highways could be automated 25 years later. And they did another one in the 1960s, again at the World's Fair in New York, showing that future vision. Got a lot of attention. Millions of people saw the exhibit and got excited about it. But the technology wasn't really ready at that point. It took a few more generations of technology to get the computer hardware and software and sensor technologies to the point that this starts becoming feasible.
That's fascinating. Yeah, that certainly makes sense. So, and so then, can you tell us a little bit about the work that you do today at Berkeley?
Yeah, well, we work on a variety of projects at Berkeley. I'm actually semi-retired myself, so I only work on a limited number of projects, but we have a variety of projects to try to test the performance of automated vehicles and test how drivers actually use the systems. And in recent years, we've especially emphasized automated truck platooning and cooperative adaptive cruise control for passenger cars. So in both cases, we're making use of forward-looking sensors that detect the distance to the vehicle in front of you, and communications between the vehicles. So those vehicles are communicating with each other 10 times per second, exchanging information about where they are, how fast they're going, what direction they're heading, and especially, are they about to put on the brakes, or are they going to give an acceleration command? And that way, the other vehicles in the immediate vicinity know what they're going to be doing. And that's how the connectivity makes it both safer and smoother, and helps make a contribution to relieving traffic congestion as well by smoothing out traffic disturbances. Now, we also work on the policy side. We've done technical advice to the state of California in their work developing the regulations to govern the testing and the public operation of automated driving systems in the state of California. And we do a lot of traffic simulations as well. So experiments with vehicles are really expensive. So we can afford to equip a few vehicles and do tests on them, but we can't equip hundreds or thousands of vehicles and look at what happens if we put them all out on the road together. So we develop mathematical models of the vehicle behavior based on the tests of just a few vehicles. And then we put those into traffic simulations and study what would the effect be if we now had 10% or 50% or 100% of the vehicles on a section of roadway equipped with the connected and automated technologies.
Gotcha. And so, and the research work, that's all fascinating. The research work that you're doing, is a lot of it for the benefit of Caltrans, or are you working in service to, or maybe in partnership with auto manufacturers and and some of the high-tech companies that we hear about?
Well, it's divided among a variety of different sectors. So we do a lot of work for Caltrans. That's been the core sponsor of the program. But we also do a lot of work for the U.S. Department of Transportation and work for the U.S. Department of Energy as well, because the Department of Energy is really interested in the energy consumption implications of this. And we do some limited work with industry, but there are some interesting challenges because of intellectual property considerations that most industry sponsors want to be able to own the products of the research, but when we're working in a public university, then those research results need to be available to anybody to use, and that's sometimes a conflict with companies' proprietary interests.
I see. Yeah, that makes sense. All right. So you referred to truck platooning. You also talked about vehicle-to-vehicle communication and vehicle-to-infrastructure connectivity and communication as well. And so some of us have heard different things about that as you read online or you read in media publications. And I think you and I talked a little bit briefly about some of the things that you read online are pretty far-fetched, and some people think we're going to see level 5 autonomy in the next year or two. And you made a quick comment that some of that is a little overhyped. And I was wondering if you could tell us a little bit about what you see as sort of the common myths versus common realities of what your perspective is of what really is realistic that could be coming online in the future.
Yeah, well, and there's a wide range of automation concepts and automation technologies that will get implemented at different times and in different places. So what we really have to be conscious of is how diverse this whole field is. Systems that are designed for operation on highways at high speed are really different from systems that are designed to operate at low speeds in urban areas. They're serving different purposes. They have different technological challenges. But overriding everything is safety, safety, and safety.
Sure.
What does it take to design one of these automation systems so that it can be demonstrated to be at least as safe as human drivers are today? And one of the big myths that's out there is that human drivers are really bad and human drivers are really unsafe. But when we look at the traffic safety statistics, we actually find out they're remarkably safe. Um, Fatal crashes occur about once for every 100 million miles of driving. And if you think about an average of, say, 30 miles per hour, if you consider both low-speed urban and high-speed intercity travel, that represents 3.4 million hours of driving, or a mean time between failure that's comparable to the vehicle being able to drive 390 years, continuous 24/7 driving between fatal crashes.
Wow.
So now as an engineer, you start trying to think, how am I going to design an automation system that's going to have a longer mean time between failures than that 390 years of continuous 24/7 driving? That is amazingly difficult, and nobody really knows how to do that yet, which is why just about all the systems that are under development are going to be for very limited operational design domains. So operational design domain is the term that describes a whole set of conditions in which that system is capable of operating. So that can mean what class of road, what kind of traffic speed, what type of traffic density, but also what weather, what lighting conditions, and what supporting infrastructure elements are needed in order for that system to work. And what we're going to see is the systems that become available in the coming years are going to be designed for very, very strictly limited operational design domains. They're not going to be able to drive everywhere. They're only going to be able to drive under very limited conditions. And different companies are pursuing different niche applications that would operate under different sets of conditions and provide different kinds of services. But the notion that you're going to have a car that you're going to get into and you tell it where to go and it'll take you anywhere you want to go is really science fiction at this point.
Yeah. So then what? So you're saying that what you think is more realistic is, small, limited implementation of level 5 autonomy or that kind of automation. Can you give us an example of what that might look like?
Well, first I have to clarify the levels. So level 5 actually means a system that's able to drive everywhere under all conditions in which people are able to drive. And the companies that have been at this for at least 10 years, so the ones who've actually got some experience under the belts, know that that is a dream for a very, very, very distant future, if ever. That may never actually happen. So a lot of people are working on level 4 automation. So level 4 is the level that's capable of doing the complete dynamic driving task and ensuring safety, but within a limited operational design domain. And that's where we have lots of different applications. So this is, for example, commercial vehicles are much more likely to adopt this before personal private vehicles for some very good economic reasons. And we see some interest in long-haul trucking, so that would be a high-speed intercity driving type operation. But we also see interest in low-speed urban package delivery. And those are two completely different goods movement applications, but they're both getting quite a bit of traction these days with a lot of investment going into companies that are working on that. And then we see low-speed people movement for things like first mile, last mile access to transit facilities. So getting people to and from those transit stations in low-speed shuttle vehicles, which have very limited capabilities, but in certain applications they can work. And then there are a lot of people trying to implement urban taxi services as well. And that's quite a bit more challenging because to get to the urban taxi type of operation, you've got to deal with a wide range of traffic conditions and road conditions. It still might be limited speed range, and it would be only within an area that the companies have very carefully mapped so that they know exactly where all the road boundaries are, where all the traffic signals are, where all the pavement conditions are okay or not okay. So there's a lot of attention going into that.
So you listed 3 really good examples that a lot of people hear about in the news. So so when you talk about first mile, last mile people movement, do you foresee the possibility that that it may not be too far off before we're able to see fully automated, like downtown circulator, small shuttle bus type vehicles. Is that a realistic possibility in the coming years?
I think that's a realistic possibility, especially if they can be given some protected infrastructure. And this is
Okay.
where the infrastructure becomes really critical, because if they can operate on an infrastructure that has some degree of separation from the rest of the traffic and some degree of separation from the pedestrians and cyclists, then it becomes a whole lot easier. But as soon as those vehicles have to be able to interact with all of the other road users, it becomes really challenging for them to be able to detect all of those hazards and to be able to respond. And
Right.
the result of that is they wind up going slower and slower because they need time to be able to respond to, let's say, a surprise pedestrian popping out from between two parked cars, or a bicyclist suddenly zooming across their path at high speed from behind a building where they wouldn't have been visible until just a couple of seconds before they come into sight. So scenarios like that are really challenging, and the more the infrastructure can be separated, the easier it is to get systems to work.
Right. And so to that point, then, the example you gave about, the fully automated taxi, everybody talks about the Uber, so the someday Uber fully driverless taxi. Is that the sort of thing that you think is still quite a ways off?
Well, I think those taxi services will probably become available within the next year or two in some very, very limited situations. Like there is a number of them testing in the Phoenix area, and they're testing in a suburban environment where you've got wide streets that are really well marked and you don't have much pedestrian or cyclist traffic. And Waymo, which is the Google spinoff, is doing testing right here in Silicon Valley. They're my neighbors. I live just a few blocks away from them. And I encounter their vehicles on the road all the time. So they actually have a permit that they're allowed to do testing without a driver in the vehicle here in California, but they're not yet ready to start doing that. So even though they've had the permit for more than a half year, they still haven't begun the testing without the drivers on board, because the drivers still need to intervene when they get into situations that are too challenging for the automation.
Gotcha. And then the third example that you brought up about maybe a last mile package delivery that, we certainly hear Amazon and to some extent UPS and FedEx. How far off do you think the beginnings of that sort of thing might be?
And that's actually going to depend on finding the right business model. How do they actually make that into a viable business model that can get the package to the customers? So, for example, you've got that vehicle that's going to stop out in the street in front of your house. How does the package get to your front door if you're not home?
Mm-hmm.
So there's a whole other set of challenges that have to be solved to make that really work, because it might only be viable if the customer's at home at the time that the vehicle arrives. And those could run at really low speed because you don't have an impatient passenger on board. But then the challenge is, how do you do that without interfering with all the other traffic and slowing everybody else down?
Right.
So some of those companies are working on small profile vehicles that might be able to squeeze in between the regular traffic lanes and the park traffic, or they might want to share bicycle lanes, and then that could be a challenge with bicyclists as well, who may not be so excited about sharing their lanes with these other vehicles that might be traveling slower than they want to travel.
Sure.
So there are a bunch of issues that have to be worked out with that.
Gotcha. That makes sense. All right. Last couple of questions then. So then, as we think about these different types of implementations, what do you think, departments of transportation and government agencies should be doing today and looking forward into tomorrow to be ready for this coming technology of connected and automated vehicles?
Well, the first thing I always tell them is to start putting up the communication infrastructure so that they can actually connect with those vehicles. And start installing the 5.9 gigahertz DSRC wireless communication, so that, for example, the traffic signal controllers can broadcast not just the current traffic signal phase, but also the countdown to the next phase to all of those approaching vehicles, which has really important safety and efficiency implications. But then the other thing I always advise them is to keep in mind that the dominant factor here is uncertainty. Nobody really knows exactly how this is going to evolve or how quickly it's going to evolve. So whatever decisions you make, you need to make sure that you're not boxing yourself into too narrow a box based on a specific technology assumption. So try to make sure the roads are well maintained, the markings are well maintained, but don't go about starting to eliminate all your parking facilities, because the need for parking is not going to disappear. And don't expect that you're going to be able to narrow your lanes significantly, because you can't really do that until you've got a high population of vehicles that can use those narrow lanes. This is an area that has a very significant chicken and egg problem, because you need both the infrastructure and the vehicles to be compatible with each other, and the timescales for development on the infrastructure side and the vehicle side are not generally in sync. That's one of the big challenges we face.
Yeah, and so as you talk about narrowed lanes, I mean, that leads me to my last question, which is, in what ways do you think connected automated vehicles and new technologies are going to change the way DOTs design and construct highways into the future?
Yeah, I think there will be issues associated with, for example, what you do on width of lanes eventually. There'll be a lot on the electronic infrastructure. How do you communicate with the vehicles? And then with the truck applications in particular, there could be some pavement implications. And I also try to encourage people, if you've got a corridor with high truck volumes, why don't you look at dedicated truck lanes? Because if you can separate the trucks from the light duty vehicles and put your really heavy duty pavement in the truck lanes, but you don't have to do it in your light duty vehicle lanes, you might be able to save money, both construction and maintenance. But also, if all those trucks are sharing that lane and don't have to share it with other vehicles, the truck automation becomes feasible sooner. It becomes easier to implement the automation of the trucks in an environment where the trucks only need to coexist with other trucks, and with truck drivers who are properly trained in how to interact with trucks. The large majority of the crashes that involve trucks are not the fault of the truck driver. They're the fault of the driver of the other vehicle who did something that they shouldn't have done in the vicinity of the truck. So being able to separate the trucks from the cars could really be an advantage in terms of both safety and operations.
Gotcha. Well, great. All right. Well, Steve, thank you. That was very fascinating information. I really appreciate the conversation.
Okay. All right.
So,
talking with you.
Yeah, thank you so much. Well, that concludes this episode of The Future of Highways. Steve, I thank you so much for making time and for being our guest. And thanks to everybody in the audience. And please join us again on the next episode that we have on The Future of Highways. So have a great day.